Okay, so now I will briefly talk about homology mapping tool. So it's available in analysis tool, and it's here called homology mapping. And the idea of the tool is very simple. So when we have epitope from IEDB, and we know the protein which epitope came from, we can find the homolog for that source protein in PDB, and then try to map epitope residues to found structure and see where they are in the structure. So that's the basic idea. So, and it has very simple interface. So if you know epitope ID, you can type here ID and go with epitope ID, or you can go with other functions. So there are different examples, 5 examples which cover all situations. For example, I selected example 2. So I have linear sequence, and I need to specify the position. But if you do not specify the position, it's okay. It will be searched for in the sequence that epitope. And what I can see on the result page. So I can see my submitted sequence with highlighted epitope. So in this will be highlighted in orange if it's exact match, and in yellow if it's not exact match. So you can immediately recognize if it's match or not match. So, and below, if you scroll below, you can see the alignment between the sequence we submitted and between the sequence here from PDB. And this is the area of epitope highlighted in orange. And other coloring means that red are residues which are exposed, and blue which are buried, which are not accessible by circuit, and not colored is something in between. Also, you can see here the markout for secondary structure, and you can read definitions here. So, and okay, so and if you scroll down, you will see another hit. So it's similar to blast hits, but they just map epitope. So, and again, you can look at, for example, in that case, you see only a small part of epitope can be mapped. And sometimes people ask, I know that my protein has homolog sensitivity. Why it doesn't show in homology in this tool? It doesn't show if your epitope has no mapping. So if it would be empty, that hit wouldn't be shown. So we filter out hits which have no, on which epitope cannot be mapped. So, and in that case, for example, we can see that epitope is mapped on very gapped region. So, and again, you can click on 3D structures here and go back to PDB. So let's go back to PDB to look at the structure specific. And you can change, so here. Okay, and then also you can use a 3D viewer. So when you click 3D viewer, so there you will see the homolog from the PDB with the highlighted in blue region where epitope is mapped. So it doesn't mean that it's your exact epitope, because you need to look at the alignment. It can be some gaps. It's just a region where your epitope is mapped. So, and I will show in a minute how to play with Epitope Viewer. Again, what else you can do with that tool? You can select alignment type. It was pairwise by default. You can select multiple, and here you can exclude some of the sequences. So if none is excluded, and all hits which you selected will be visualized. So I click reformat here, and I will get that picture. So So that's a multiple alignment of all homologs for the input sequence. And this region where epitope is mapped. So, and based on that, looking at that picture, you might select, for example, to proceed with experiments with some specific sequences. And what you need to keep in mind in that case, okay, I will show another example, and then go back to what So you also can use it for conformational or discontinuous epitopes. They just need to be provided in that format. And again, they can be highlighted as spread along the protein sequence. And now you can look at like how many residues of mapped residues are accessible or buried, and you can already from that information you can make a conclusion about how the epitope in homolog will be accessible for antibody without going to 3D view.
This really has to do with charge, not specific knowledge in terms of modeling whether it's on the outside or the inside, because you have a negative charge and a positive charge side chain. They're both inside the molecule, they're bound to each other parts of the structure, but they're not really on the outside. This is really just charge.
This solves accessibility.
Yeah, so it solves hydrophilicity.
No, it's based on the structure.
Based on the structure.
Yeah, it's not based on amino acid property. It's based on the structure.
So this is only for the known structure.
Yes, that's
PDB.
Yes.
You can do mapping in your own model structure or
not modern structure. So yeah, you can take any sequence and then the tool will look up for homologs in PDB. Again, so let's look on the 3D view, and you can see that this mapped region is accessible for antibody. And some things to keep in mind when you use homology mapping tool. So you need to think about species, because in that case we do take species into account. So you need to keep in mind if you want, for example, to filter, but we don't have that option actually, to filter for some specific species. So in that case, you just need to go to PDB and to look for maybe for species if you're interested. So another thing to keep in mind is that I already mentioned that if a epitope is not mapped, then you won't get a result. So, and the result, so you did some, you used the homology mapping tool, and then you didn't use it for a year, and you go back and you see the results changed. Obviously, they might change because PDB updates quickly. Yes.
You say the second goal is the different way. I can't follow.
Okay, so that's what I already showed. That like in that example, if, for example, okay, for example, that's my epitope, and it's mapped on the sequence from PDB. If the sequence from PDB would end here, like only would be such short.
Oh, I see. It's not there.
Yeah, if epitope cannot be mapped, you won't get that result.
So the protein's not full
No, protein can be not fully sequenced, but epitope should be in that region, should map that region. So, and we just not show such results. So, yeah, and that causes some confusion. As I said, people contact me and say, I know that this homolog exists in PDB, but why it's not in your tool? So, because I say, because your epitope is outside the homology region. Okay. Okay, so to keep for the last bullet, I suggest you when you use the tool and especially publish the result, just put a date when you date for when you use the tool. So when people repeat the result, they will be aware that they can get different results. Yes.
When you're choosing from the people who are choosing a structure of formula, what would be the recommended thing?
So the question was when we choose the homolog from CTD in the case of that tool or in general? In that tool. In that tool, we have pretty strict criteria, and they are in health. So we have very low value, and we have some blood score. So if you are interested in specifics, they are listed in the health. So, and we actually provided in the first incarnation of the tool, we provided the user option to play with those parameters, but when we decided to take them off. So maybe if you're interested, you can put them back, so you can play with parameters.
No, I was actually mostly interested, like, so what works, rather than.
So those are pretty strict formulas. So because we didn't want a huge shift, which will take like an hour maybe to come out. So that's a problem, because if you go with very low threshold for like homology, the tool will just be picking up, searching and visualizing, and it will take a while.
So my concern was not even with the time, but even actually able to use the template as borderline form.
So yeah, I think the criteria which we need to find something common. So I don't want to speculate because I don't expect to remember numbers. Okay?
And for see the right full method. One is the problem, and another one is the distribution, right? For those who measure,
you mean why? The question is why we have only two methods?
Not no. If I can my I use the question to give you the score expert that is 4 for contribution. If I can give this 4, so I can compare which method is possible. Yeah, so when you give the structure, so you can give me what form for the storage and for the. So in this case, I decide which method that you have more fun.
So the question was what method to track and how to choose between this cutoff and Epitope basically. We would recommend to use both. And which one to track? You can decide, again, you can go with consensus. For example, if both methods agree, you can say, oh, that's very good. But again, it's not always the case. For example, for RSC, we saw that Epitope was pretty good for prediction, but this cutoff was completely useless. So we don't know why. So different methods use different approaches, and different situations might ask for different approaches. So yes, and different confirmations too.
But if you verify this on method, if your TI recognize the own right? compare structure on the maybe this is the only solving check. So if I click on this all sides.
So I'm not sure I can repeat the question. So it's mostly discussion. Yes, we probably can discuss in more details after on the break session. Yes, and we can look at some specific examples which you have maybe. So and but basically I can say it's not too many methods to choose from. So it's not that difficult to use all of them. Yes, and then to decide which method you try. And especially if you got some experience with using those methods, if you use them repeatedly, then you will develop your gut feeling probably. So, okay.
So Julia, we're ready.
Yes, yes. Let's.
Please go ahead with the homology.
Yes, the homology mapping. Okay, so I'm briefly go through Epitope Viewer. Just to show you how you can play with the tool. So because you might not aware about different options which exist. So that's my goal. So to briefly to show you what you can do. For example, you start with the structure. So it's the structure which you already saw in homology mapping tool. So what you can do? Okay, you can look at tutorial first. It's available. So you can look at tutorial which tell you exactly what I will tell you now. So and first you can save 3D image. What you can see on that window for the structure, you can save that as 3D image. And you also can save. Okay, I will show later. So and you can rotate, move, and zoom the structure using left, right, and middle buttons of your mouse. And then you can start playing with tools. There is this tool tab, and it has visibility, colors, labels, lines, and recentering. So, for example, for visibility, if by default you have atoms and bonds, so there's something what you need to know. So all what you do will affect either atoms and bonds or ribbons. So here we see only ribbons. So we don't see any atoms and bonds. So if I do visibility and if I didn't change anything, and if I start clicking here, nothing changes. Because oh, it doesn't work. So the thing is, you need to select ribbon, and then you can select any chain, for example, and like H and L, and they disappear. So they become invisible. So. And next, what you can do, for example, I decided to zoom in on the epitope, which is highlighted in blue. And if I just click on antigen, it will become represented in those volumetric representation with atoms and connections between atoms. And again, when I start playing with tools, I can use labels. Because now I have atoms and bonds. If I click labels and click change all, because I made those two chains disappear, I will see labels for each residue. Again, if I click ribbon and click all, nothing will happen. And it will say, oh, labels do not work. Okay? So that's the most important thing which I tell you all the time. So, yeah. So, and now you can start playing with color. Again, you can click colors, you can click at atoms and bonds. Now there will be the whole palette of different colors, and you can click change all, and all your atoms for epitope will change color. But you see, ribbon is still blue. So if you want also ribbon to be red or whatever color, you would click here, it's now not visible, you click ribbon, and then you select color, and you click change all, and then this blue will become the selected color. Okay, so that's, in reality, it's a very easy tool to play. Just remember exactly what you are doing. Items or ribbon. Yeah, that's what I did. So I click ribbon, and I selected green, and I click change all, and all change all you can click. So now you can use the two lines. Again, that will be used for atoms and bonds, and you click on any place on the, like I clicked on that atom, and it will be shown which atom exactly I clicked, and then I click on the second atom again, and then the line will be drawn, and the distance between those two atoms will show up. So yes, this one, and this one. So now I can go to shortcuts. Shortcuts allow to change background. And you click here, you can select any background you want, for example, gray. And you will have that picture. So now you can change style. For example, I want my epitope residues to be in more prettier representation, like PPK. Again, I select style, select atoms and bonds, PPK, and then I click change all. And this will affect only those residues which go in atom and in atom representation. It wouldn't affect the rest of the chain. So now I can go to shortcuts, and I can start coloring my epitope, for example, by conformational type. So you can see it will be coil, tone, helix in different colors. And I can also save that image again. For example, I like that image, and you can create different and very fancy images for a presentation or just for amusement, for gift cards. Yeah, that's it. So that's options which are there. So, and I want you to know that they are there, and you can play and make nice pictures. And actually, quality of the 3D image might be very, very good, even for large. Okay. I don't.